Welcome to Aryabhata Ashram. This is a very important daily answer writing question practice for maths optional. Here is the question. Show that the orthogonal trajectories of confocal ellipse x square upon a square plus lambda plus y square plus b square lambda is equal to 1 is self-orthogonal. This is asked in civil services examination many times, IAS 1993, 2003 and recently in some IFoS examination. Now this is a very repeated question, oft asked question, but still I find people making some mistake or they are not able to eliminate the parameter lambda. So I am coming up with a very elegant way of doing it, that is, so this is the equation of confocal ellipse. X square upon a square plus lambda plus y square upon b square plus lambda is equal to 1. So the first mandate is that we differentiate with respect to x. Differentiate with respect to x, we get 2x upon a square plus lambda plus 2y dash b square plus lambda is equal to 0, where y dash is dy by dx. And one can write x upon a square plus lambda is equal to minus y dash upon b square plus lambda. Now, one of the elegant way of taking away this lambda is that if I subtract is this ratio, so this can be written as, if it is subtracted, dividendo is done. So x minus become plus and a square plus lambda minus b square plus lambda. So this amounts to x plus y dash upon a square minus b square. Now what is the point here that is to be made is that lambda is eliminated. Otherwise, if you are going by the long route, it will no doubt take you a great deal of time, but this is a cheeky way of reaching your answer. So this is what I get, that is x upon a square plus lambda is equal to minus y dash upon b square plus lambda is equal to x plus y dash upon a square minus b square. So I can use this as 1, 2 and 3. So if I take 1 and 3 together, so I can write x by a square plus lambda is equal to x plus y dash upon a square minus b square. So if I multiply this, if I call this as equation number 4, and similarly if I take equation 2 and 3 together, so I have this y upon b square plus lambda is equal to minus of x plus y dash upon a square minus b square y dash. So if I call this as equation 5 and if I multiply equation 4 by x and equation 5 by y and add them together so what do I get? I get x square plus lambda plus y square plus b square plus lambda and I see these fellows together common. So this is your x plus y dash upon a square minus b square, correct? And this is your x minus y by y dash. Okay, and this x square plus x square upon a square plus lambda plus y square plus b square plus lambda is nothing but 1. So this is your x plus xy dash a square minus b square x minus y dash. So if in orthogonal trajectory, if we replace the slope dy by dx by minus dx by dy, that is if I replace y dash by minus of y dash, so this would be your x minus y dash upon a square minus b square, and this is x plus y dash. So what we see, that the differential equation for this orthogonal trajectory, they are same, so they are hence self orthogonal. So one need not necessarily solve the differential equation and reach out to the confocal ellipse. Now there is a pertinent linkage between fluid dynamics, where they ask you tan inverse of z. So W is a complex potential phi plus I psi. So you have to find out that velocity potential and streamlines are confocal. It's not confocal, but what is it? It is coaxial circles. So why I am writing this? Because it has linkage with fluid dynamics and it helps me to do this. Sometime the examiner will give you the complex potential, as that is W is equal to C cos hyperbolic z is equal to cos hyperbolic omega, and this amounts to a confocal ellipse. And whatever this, these are coaxial circles. So if you understand complex potentials with regard to orthogonal trajectory, with regard to differential equation, you will be making a very quick connections and networking between the two modules, which is very significant. In our online mode, we are providing you only one question per day, but if you come offline, we are making you practice 5 questions per day. You can come and visit our offline centers, that is 47 ground floor, Old Rajendra Nagar. This is near Batra Medical and it is situated in New Delhi. For those of you who have any query, and this time practice that we have allotted is 6 to 7 p.m. and this is the time where you are not very productive and you can utilize this to do it. If you like our content, please do also visit our website aryabhatashram.com. You can visit our offline center. As I reiterated, it is 47 ground floor near Batra Medical, Old Rajendra Nagar, New Delhi, or you can make inquiry on our given numbers that is given below. Thank you.